Welcome to month 1 of the Data Engineering Tech Lead track. This session marks a pivotal shift in how you think about data engineering, moving from building individual pipelines to owning an entire platform strategy. Today, we're covering data platform strategy. We'll work through 4 major areas: crafting a platform vision, assessing technologies systematically, building multi-year roadmaps, and evaluating vendors objectively. Here's what we're covering today. 4 hours of combined lecture and hands-on work. The focus is strategic, thinking at the platform level, not the pipeline level. The challenge scenario is a fintech company that needs to modernize its data platform. By the end, you'll produce 4 deliverables: a platform vision document, a technology assessment matrix, a data platform roadmap, and a vendor analysis report. This is the kind of work that distinguishes a tech lead from a senior engineer. Senior engineers build excellent systems. Tech leads decide which systems to build and convince others why. Let's be clear about what success looks like today. There are 5 objectives. First, developing a platform vision. This means connecting business strategy to data infrastructure, not just picking cool technologies. Second, technology assessment. You'll learn a structured framework so decisions aren't based on gut feel or what you saw at the last conference. Third, roadmaps. Not vague "we'll figure it out" plans, but concrete phased approaches with milestones and exit criteria. Fourth, vendor evaluation. Objective, weighted scoring that you can defend to a CFO. And fifth, executive communication. You need to present all of this to stakeholders who don't speak data engineering. Here's the 4-hour flow. Each hour has a distinct theme. Hour 1 is about vision, understanding modern architectures and where the industry is heading. Hour 2 gets tactical with technology assessment frameworks. Hour 3 is where you start building your roadmap. And Hour 4 brings it together with vendor analysis and presentations. The session gets progressively more hands-on. By Hour 3, you'll be deep in your challenge work. Each hour's content feeds directly into one of the 4 deliverables. We're starting with the most important question a data engineering tech lead must answer. What does our business need from data? Notice, that isn't "what technology should we use?" That's the mistake most engineers make when they step into leadership. They jump straight to tools and frameworks. A platform vision starts with 4 questions. What does the business need? Where are we today? Where do we want to be? And how do we get there? The first question is the hardest because it requires thinking like a product manager, not an engineer. Real-time insights, regulatory compliance, self-service analytics. These are business capabilities, not technical features. This is the individual contributor to lead transition in action. Before you can craft a vision, you need to understand the landscape. 5 major architectural patterns dominate modern data platforms. The data lakehouse is the current darling. It combines the reliability of a warehouse with the flexibility of a data lake. Delta Lake, Apache Iceberg, and Apache Hehudi are the key formats enabling this. Data mesh is an organizational pattern, not a technology. Each domain team owns and publishes their data as products. It works well in large enterprises with autonomous teams, but it requires significant organizational maturity. Data Fabric is metadata-driven and focuses on automated integration. Think of it as the AI-assisted approach to connecting disparate data sources. Traditional warehouses are still very much alive. If your workloads are well-defined and primarily analytical, a modern cloud warehouse is perfectly valid. And streaming-first architectures are essential for IoT, financial services, and anything requiring real-time decisions. Let's dig deeper into the 2 most debated patterns: lakehouse and data mesh. The lakehouse gives you a unified architecture. One copy of data that serves business intelligence, machine learning, and streaming workloads. The key enabler is ACI transactions on the data lake, something that was impossible 5 years ago. Delta Lake, Iceberg, and Hootie solved this problem. Data mesh takes a fundamentally different approach. Instead of centralizing data, each domain team owns their data products. The platform team provides self-serve infrastructure, and governance is federated, central standards with decentralized execution. Here's the insight that many people miss. These are not mutually exclusive. Many successful organizations adopt a lakehouse as the underlying technology while applying data mesh organizational principles. The lakehouse is the how. The mesh is the who owns what. Understanding this distinction between technology patterns and organizational patterns is critical for tech leads. Let's look at a real-world platform evolution that mirrors the challenge you'll be working on. The legacy state: on-premises SQL Server warehouse, manual ETL processes, 24 to 48-hour data latency, 3 data engineers, and $15 million in annual infrastructure spend. Many organizations are here right now. The migration phase is messy. You run 2 systems simultaneously, the old warehouse and the new cloud lake. You launch streaming proofs of concept while keeping the lights on. You deploy a data catalog. And costs temporarily increase because you're paying for both environments. The target state: a modern lakehouse with sub-minute latency, self-service analytics for over 200 users, production machine learning capabilities, and multi-region compliance. 3 lessons from organizations that have made this journey. Start with business outcomes, not technology choices. Plan for the dual running costs during migration. Leadership always underestimates this. And invest in data governance early, not as an afterthought when you're already drowning in data quality issues. Welcome to Hour 2. We're shifting from vision to evaluation. The core challenge is this: there are dozens of competing technologies in every category: ingestion, processing, storage, orchestration, quality. Each has 5 to 10 credible options. So how do you choose? 3 sub-challenges. First, vendor marketing versus reality. Every product claims to be scalable, cost-effective, and easy to use. Your job is to see through the marketing. Second, balancing innovation with stability. Bleeding-edge tools are exciting but risky. Battle-tested solutions are safe, but might not meet future needs. Third, organizational context matters more than technology benchmarks. The best tool on paper might be wrong for your team, your budget, or your timeline. Here's the structured framework for technology assessment. 5 dimensions. Scalability. Not just can it handle our current load, but can it handle 10x growth over 3 years? Think about both compute and storage elasticity. Cost model. Total cost of ownership is what matters, not just the license fee. Include compute costs, storage costs, personnel costs for training and maintenance, and the cost of migrations if the tool doesn't work out. Ecosystem integration. Does it play well with your existing tools? Can it connect to your data sources? Integration friction is the number 1 hidden cost in platform decisions. Talent availability. Can you hire people who know this tool? Is there a training ecosystem? A technically superior tool with no talent pool is a dead end, and vendor lock-in risk. How portable is your work? Does the tool use open standards? What does the exit strategy look like if you need to switch? Think about which of these dimensions matters most for a fintech company expanding to new regulatory jurisdictions. The answer is nuanced. Compliance and talent availability might outweigh raw scalability. Now let's put the framework into practice. This is where you build your own evaluation matrix. The example shows 3 ingestion layer options: Azure Data Factory, Apache Kafka with Kafka Connect, and Fivetran. Each is scored across our criteria with appropriate weights. Notice the weights aren't equal. Scalability and cost efficiency get 20% each because they're the most critical for this scenario. Security and compliance get 10% because all three options meet baseline requirements. The key to this exercise is intellectual honesty. Don't inflate scores for the tool you're already comfortable with. Score based on the criteria, not your preferences. Have a colleague score independently, then compare. Disagreements reveal hidden assumptions. Before we move to roadmaps, let's address a strategic fork that every platform migration faces. Do you go fully cloud-native or adopt a hybrid approach? Cloud-native gives you elastic scaling, managed services that reduce operational burden, and faster innovation through quick provisioning. The trade-off is lock-in risk. Deep integration with one cloud provider makes migration harder down the road. Hybrid gives you data sovereignty, keeping sensitive data on-premises for compliance, and enables gradual migration that reduces risk. But you pay for that with higher complexity. Managing two environments means more networking, more security configurations, and more things that can break. Data gravity is the elephant in the room. Once your data is in one place, moving it is expensive. This is true whether it's on-premises or in the cloud. Your migration strategy should account for where data naturally gravitates. For a fintech scenario with SOC 2, GDPR, and PCI DSS requirements, neither extreme is likely the right answer. A thoughtful hybrid approach that transitions to cloud-native over time is often the pragmatic choice. Welcome to Hour 3. You've assessed the landscape and evaluated technologies. Now it's time to build a plan. A data platform roadmap isn't a wish list. It's a structured, phased plan with 5 components. Define strategic objectives. What business outcomes does the platform enable? Not deploy Spark, but enable real-time fraud detection saving X million in losses. Assess current maturity. Be honest about where you are. Use a maturity model so the assessment is structured and defensible. Design the target architecture. What does the end state look like? This should be specific enough to estimate costs but flexible enough to adapt. Plan phased migration, quarterly milestones with clear exit criteria. Each phase should deliver measurable value, not just we set up infrastructure. And define success metrics. How do you know the platform is delivering? Latency targets, cost per query, user adoption rates. The individual contributor to lead shift is especially visible in road mapping. Engineers want to jump to phase 1 tasks. Tech leads need to first articulate why the phases exist and what success looks like at each gate. Let's break down the 6 essential components of a platform roadmap. Business alignment maps platform capabilities to revenue drivers. If you can't connect a platform investment to a business outcome, it won't get funded. Maturity assessment gives you an honest baseline. Score your current capabilities across ingestion, processing, storage, governance, and self-service. Target architecture is your North Star. It should include the logical layers: ingestion, processing, storage, serving, and governance. Quarterly milestones make the roadmap actionable. Each milestone has concrete deliverables and exit criteria, the conditions that must be true before you move to the next phase. Investment plan connects the roadmap to money. Budget allocation, ROI projections, and funding timeline. This is what executives actually care about. And risk assessment identifies what could go wrong and how you'll handle it. Migration failures, talent shortages, budget overruns, vendor changes. Most organizations do well on the first 4 components, but neglect risk assessment and success metrics. Here's what a phased roadmap looks like in practice. 4 phases over 2 years. Phase 1 is foundation, Q1 to Q2 2026. You set up the cloud data lake, run a streaming ingestion proof of concept, and deploy the data catalog. Budget: $450,000. The exit criteria are: the lake is operational with 80% of sources migrated. The streaming proof of concept is processing 1 million events per day, and the catalog is indexing all critical datasets. Phase 2, real-time, Q3 to Q4 2026. You move from proof of concept to production streaming pipelines, implement the governance framework, and achieve compliance certification. Budget: $600,000. Phase 3 is self-service, Q1 to Q2 2027. This is where business users start getting direct value. Analytics platform launch, machine learning infrastructure, and user training. Budget: $500,000. Phase 4 is scale, Q3 2027 onward. Multi-region deployment, performance optimization, and legacy system decommission. Budget: $400,000. The total is roughly $2 million over 2 years. The scenario provides a $5 million annual budget, so this is achievable. But remember to also budget for maintaining existing systems during the transition. Dual running costs are real. Welcome to Hour 4, the final stretch. You've built your vision, assessed technologies, and created a roadmap. Now you need to make specific vendor decisions. The challenge focuses on 3 key decisions that every data platform migration faces. First, your cloud data platform. Azure Synapse, Databricks, or Snowflake, each has distinct strengths and trade-offs. Second, orchestration. Apache Airflow, Azure Data Factory, or Prefect. This choice affects how you manage every pipeline in your platform. Third, data quality. Great Expectations, dbt tests, or Monte Carlo? Data quality is the foundation of trust in your platform. These 3 decisions will shape your platform for years. They deserve structured analysis, not gut feelings. Vendor decisions are among the most consequential choices a tech lead makes. A wrong choice can cost millions in migration effort. Let's walk through the vendor comparison matrix for the cloud platform decision. We're comparing Azure Synapse, Databricks, and Snowflake across 6 weighted criteria. For real-time support, Databricks leads at 5 out of 5. Its structured streaming engine and Delta Live tables are purpose-built for real-time processing. Synapse and Snowflake both score 3. They support streaming, but it's not their core strength. Cost at scale favors Synapse at 4 out of 5, thanks to Azure's integrated pricing model. Databricks and Snowflake both land at 3. Their consumption-based models can get expensive at scale. Machine learning integration is where Databricks dominates at 5 out of 5. ML Flow, model serving, and a built-in feature store make it a complete ML platform. Snowflake scores lowest here at 2. Governance tools are roughly equal across, all 3 at 4 out of 5. Unity Catalog, Microsoft Purview, and Snowflake's access policies all provide solid governance capabilities. Your task is to complete this analysis for all 3 vendor decisions. Use real-world constraints from your organization, not just what looks good on paper. Challenge your own assumptions. If you scored a tool high, make sure you can explain why. Before you finalize your deliverables, let's talk about the mistakes seen most often in data platform strategy. On the void side, technology-first thinking is the #1 killer. Starting with "let's use Kafka" instead of "we need sub-second event processing" leads to solutions looking for problems. Ignoring migration complexity is a close second. Every platform migration takes longer and costs more than you think. Budget 30% extra for the unexpected. Vendor bias means using the tool you already know instead of the tool that's right for the job. This is human nature, but it's a tech lead's job to fight it with structured evaluation and missing the people factor. You can build the most elegant platform in the world, but if you can't hire engineers to maintain it, you've failed. On the best practices side, start with business outcomes and work backward to technology. Make trade-offs explicit in every recommendation. Plan for day 2 operations, not just the initial deployment. And always include both optimistic and pessimistic scenarios in your roadmap. These habits separate strategic tech leads from tactical ones. 5 things to take away from today. 1. Platform vision must align with business strategy, not technology trends. If you remember nothing else, remember this. 2. Use structured frameworks for technology assessment. Gut feel doesn't scale and can't be defended to leadership. 3. Roadmaps need phased milestones with clear exit criteria. Every phase should deliver measurable value. 4. Vendor analysis must be objective. Weighted scoring matrices exist, so you can show your work. 5. Always account for people, process, and organizational readiness. Technology is the easy part. People and process are hard. These 5 takeaways mirror the 5 learning objectives from the start of the session. Everything connects. That wraps up month 1 of the Data Engineering Tech Lead track. Next month, we move to Data Team Leadership, covering team structures, hiring strategies, mentoring, and performance management. It builds directly on today's work, because the best platform strategy means nothing without the team to execute it. Before next month, there are several offline milestones to complete. Present your platform strategy to a peer group. Refine your vendor analysis with real pricing data. Develop a total cost of ownership model for your recommended platform. Review 2 industry case studies on platform migrations. Draft an executive summary for leadership review. And gather feedback from your current data team members. Thank you for your time and engagement today.